Hello, Honors Chemistry. I'm sorry that some of you are having problems downloading the file that you need to complete the next part. So I'm going to show you how to do it, and hopefully it works for you. And if it doesn't, I'll just continue, and you can just watch this video and answer the questions on your own. So the assignment is to go through this entire document and fill it out. So part one's pretty self-explanatory. Follow the directions and answer these vocabulary terms and some of these questions. You get to part two, and this is where a lot of you are stuck. You're supposed to click on this link, and you can download. If you're a coder, you can embed it into a HTML file, but you just want to click on this. What happens is a downloadable file gets put down here. So there it is right there. It says this type of file can harm your computer. You want to keep it or discard it. Different operating systems or different computers, this might look different. Macs, you have to go through a whole bunch of different stuff to make it work. I am not a coder, so just follow the instructions or do your best if you can. Otherwise, if you have a PC, you click on Keep, and then you open it after it's done downloading. Then it just runs, and this is it. That is the program that I need you to see. So if you flip the page to where it says part two, it gives you some information that you might have to reference about formulas of different compounds, molar masses, and solubilities. You go to the next part and it says macro tab. This is the macro tab up here. This is the micro, and this is the water. So part A on the micro tab, shake some salt into the water. Whoops, I missed that. That's okay. So this is a lot more fun if you get to do it. Because who wants to? That's just fun. I don't care who you are. So what's going on? Identify the solute and the solvent. Well, if you didn't do your part A about defining vocabulary, it's going to be difficult to answer these questions. But if you did, the solute is the thing that gets dissolved, and the solvent is the thing that does the dissolving. So where's the salt? Well, it's kind of hard to tell in that. So I'm going to kind of cheat, and I'm going to click on micro and see what happens. Well, now it has a more specific salt name, sodium chloride, and I can see it's pretty obvious now what dissolved. So the salt, or the sodium chloride, would be the solute, and the thing that did the dissolving is the water, so that would be the solvent. I'll go back to micro and see what number two says. What happens to the concentration of the solution when you shake salt into the water? Well, here is concentration, little graph, and if I shake that in, you can see that it's increasing. If I click on this, it tells me an exact value. Oh, that's full, or I'm out of salt. So let me remove it and see what happens in case you missed it. What's happening in the concentration as I add salt? Add water to the container. All right, so I'm going to turn on a faucet. What happened to the concentration? I'll do that again. Explain this in terms of the solute, the solvent, and the solution. So if you do these questions and you use those terms, you will be absolute solutions gods when you're done with this. You will know solvent, solute, and solution like the back of your hand. Let some solution out of the container. All right, so let's drain some out. Watch what happens over here as I do that. Evaporation. Okay, I'm going to evaporate some stuff. So I'm not draining out the water or the whole solution. I'm just evaporating water. Huh. All right, reset all. Start over. Reset all. There it is. What volume of water is provided in the container? Where can you find that? Maybe if I click on the water tab, I can figure that out. Nope, that's a little crazy. Micro. Nope. Where can I find that? I wonder. Oh, that's right there on the scale. Empty out all the salt. Here we go. Shake it, shake it, shake it. Okay, it's empty. What is the concentration in moles per liter of the resulting solution? Show values box is a hint. There you go. Next page, calculate the number of grams of salt you added. So if you know how many moles per liter are there, you should be able to figure out how many grams of salt. Use your brains. Look at your book. Try to figure it out. If you get stuck, send me an email. Find a method to double the concentration of the solution. How can we make this thing double? I can't put any more salt in there. Maybe I put more water in. Oh, that makes it go down. So maybe if I let some of this out, that didn't change anything. Maybe if I did this. Oh, look at that. The concentration's going up when I evaporate the water. Part B, sugar. Let's reset everything. Sugar. What's the difference? Does the concentration of the solution increase, decrease, or stay the same if I add sugar? Oh, well, first, what's the solute and the solvent? Well, I think we kind of know that sugar dissolves in water, so you can figure out those vocabulary terms. What happens to the concentration? Not a sugar. You want to peek? Let's see what happened. Sugar. Oh, sorry, that was sodium chloride. Let me reset that. Sugar. So sucrose is that big molecule. You can see it's still the big molecule. They're just separated from the other big molecules. All right, that was cheating. Let's go back to macro. I am on question 4 for part B. Add some water. You can take a look. My volume went up. You see what happened to the concentration. Evaporate some. What's going on with the concentration? Next page. Question. Oh, I guess I don't have any numbers anymore. So this is going to be the question after number 6. Sorry about that. Didn't notice that the numbering stopped. So reset all. So start over. What volume of water is in the container? Well, there's the 1 liter again. Empty all the sugar out. Turn to sugar. Insert song for Taylor Swift about Shake It Up. It's all gone. What's the concentration? There's your numbers. Figure out how many grams that would be. So you have 0.9 moles of sugar in 1 liter. So all you got to do is turn moles of sugar into grams of sugar. How do we double the concentration of sugar? Well, you can explore that again. Add some water. That makes the concentration go down. Remove some of the entire solution. Well, the concentration stays the same. All that happened was you're pouring out solution. But if you remove water only by evaporation, you can see that now there's a lot more sugar in there in comparison to the amount of water. So the concentration is going to be going up when you evaporate away water. Calculate the number of grams present when the concentration is doubled. Conductivity meter observations. So let me pour some more water in here. Here's the conductivity meter. So if I take this and put it in the solution, if these positive and negative electrodes are in the solution and the light bulb turns on, it means that it conducts a circuit, which means that this water would be conducting electricity. So let me reset it and follow the instructions. So this is just pure water. Light bulb is not on. Sprinkle some salt in. Light bulb's on. Sprinkle more in. Oh. I think that's one of your questions. Reset. Change it to sugar. Put my conductivity meter back in. Put some sugar in there. Observe the light bulb. Add some more. Maybe I just got to put it all in there. What's going on with the light bulb? This thing broken? Huh. Explain your observations. Next part, have some questions about salt and sugar, and then go to the micro tab. So I'm going to reset this. You have to identify about sodium chloride and sucrose, about whether it's ionic or molecular. Do a little research in your textbook or your notes if you need to. So let's start with some sugar, or sorry, some salt. So I put some salt in there. There's not that much in there. There's only a couple crystals in there. Now what happens if I evaporate some water away? So you can see the concentration right there. So the concentration is measuring the salt in the water. But evaporate it all away. What's going to happen with that one? Huh. Let's do that with sugar, see what happens. And if you didn't know, sucrose is sugar. You just add some water. This is what you guys would do anyways. If you guys had this, you'd just be playing with it, seeing what's going on. Evaporate some water. You can see the concentration. But there's no concentration anymore because there's no more water, so there's no solution. On this page, there's a number 5. Why is the periodic table given as an optional display? Why would we need that? Well, probably so we can figure out what these compounds are made of, sodium and chloride. Let's see, this one's sugar, so it's a CHO, C-H-O, C12H22O11, salt. Well, we can kind of figure out what this is. This is a metal. This is a non-metal. You should remember that makes ionic compounds. If you have all non-metals, CHO, that's going to make a molecular compound or a covalent compound. You got some questions to answer. And then part D is just the water tab. Sketch and describe how salt dissolves in water. So let me put some salt in there. Boop. If I want to pause it, that would be a good sketch. Pay attention to how the water molecules are surrounding those ions. You remember the Mickey Mouse molecule. The ears are positively charged. There's a dipole moment, so it's partially positive on the hydrogens. We'll call those the Mickey Mouse ears. And then the mouths are partially negative. That's how salt is dissolving. Let's see the sugar. Bam! What does this thing do? Water partial charges. Oh, there's the ears that are partially positive. And then the mouth, other side of the molecule of water, would be negative.